Hello friends, so we have started the first chapter of analytical chemistry and the title is Errors in Quantitative Analysis for SYBSc paper first. Okay, up to this we have seen the definition of accuracy, precision, then different methods of expressing accuracy and precision, then numerical problems based on the accuracy and precision. Okay, so the next point is classification of errors. So what are the types of errors that we have to see? Basically or broadly, the errors are classified into two classes or two types. Errors are classified into two types. These are determinate errors and indeterminate errors. Determinate errors and indeterminate errors. There are no subtypes or no subclasses of indeterminate errors, but determinate errors are of again subtypes, or they are having subclasses. So the first one is operational and personal errors. Second one is instrument and reagent errors. Third one is errors of method, and the last one is additive and proportional errors. Okay, so this is the general classification or the general summary of the classification of errors in quantitative analysis. Let us see in detail the first main type or first class, that is determinate errors. These determinate errors are also called as systematic errors. Determinate errors are also called as systematic errors. Now, why they are called as determinate errors, or what is the definition of these determinate errors? These are the errors which can be determined. These errors can be determined or discovered when we are doing any analysis, and if the errors occurs, so these errors can be determined or discovered in that particular experiment, in that particular analysis. So that's why we can say, so these type of errors can be determined, can be discovered, and hence they can be corrected. Or they can be minimized, they can be eliminated. So the rule is very simple. As they are capable of determining, or they are determined errors, we can determine them. What is the exact error? What is the exact cause? What is the exact point that due to which the error is occurring? Okay, so these are called as determined, or we can discover where is the exact cause, where is the exact point where that errors is occurring. Okay, so determined, these errors can be determined or discovered, and hence we can correct them, we can eliminate them, we can minimize them. This is the very simple definition or idea or the concept of determined errors, and hence they are also called as systematic. We can systematically point out, we can systematically eradicate or eliminate these type of errors. Okay, these errors are subdivided into four main types. These are operational and personal errors, instrumental and reagent errors, errors of method, and fourth one is additive and proportional errors. So let us see the first subtype or subclass of these determinate errors, and the first type is operational and personal errors. So as the name indicate, as the name of this type indicate, these are operational and personal errors. Okay, so these errors are of which individual person is responsible, or that operation that person is doing, the operation that person is doing for particular analysis, for particular experiment. Okay, so that particular individual is only responsible. Due to that person only, that error is occurring. Means what? If person is having no exact technique, no scientific technique or analytical technique of how to handle this instrument, of how to handle that particular glasswares, or how to do that particular experiment, how to do that particular analysis. Okay, means one of from your class, if I call that student and do and ask him to do or to operate the pH meter, if that student is totally unaware about that pH meter, how will he or she handle that pH meter? Okay, and due to this, he or she will make some faults, will make some problems in the analysis. Okay, and all of these occur due to that particular person only, and that's why these are called as operational and personal errors. Okay, so we know that these are the errors occurring due to that particular person. So we are able to determine, we are able to fix that particular error. So that's why this is included under the determinate or systematic error. Okay, so these are generally physical in nature. These errors are generally physical in nature. These errors are generally physical in nature and occur when correct technique is not followed. Okay, then why these personal errors or operational errors are occurring? This is due to the lack of an individual or that person in the correct observations or correct technique is not following by that particular person. Due to this is the reason why the personal errors are occurring in the analysis. Okay, for example, what are the examples? If you are doing a titration, by means of a burette and pipette, and the exact end point of that titration is, let us say, 11.2 ml of that volume of that particular titrant added. The exact value is, or the correct value of that observation burette reading is 11.3 ml, but one particular student is reading this as 11.3 ml. Okay, means in the case of burette, the meniscus is coinciding to the meniscus of the solution is coinciding to the 11.2 ml, but that student or that person is taking that reading or observation as 11.3 ml. Okay, because it is very nearer to 11.2 ml. 11.3 ml is the observed reading by that particular person or by that particular student. So there is an error. Okay, so this is the error occurred due to that particular person or student. So that's why it is called as a personal error. Okay, or if one is weighing 1 gram, 1 gram of compound is weighing on the electronic balance or analytical balance, but that person is taking or he is writing in his record as 2 gram. So it is just an error due to that particular person only. Okay, so 1 gram, and instead of writing 1 gram, if that person is writing 2 grams, so this is a personal error. Okay, then sometimes mistakes are happening while doing calculations. So this is another example of personal errors. Then mechanical loss of material or sample in handling or different analytical techniques. So these are the different examples of operational and personal errors. Okay, then elimination. How we can eliminate these personal errors? How we can eliminate? This can be done, or personal errors or operational errors can be done by the repeated measurements. Repeated measurements. Repeated measurements, and this is the reason why we are taking generally 2 to 3 titration readings. While doing titration, why we are generally taking CBR, that is constant burette reading. CBR. Why? Because sometimes we get a wrong results, or due to this our personal errors, wrong results may be obtained, and due to this, to avoid this, we are trying to take repeated measurements. Okay, so by repeated measurements or by getting skills, one can eliminate these operational or personal errors. Okay, so these are very simple repeated measurements, and by taking repeated measurements and by means, in other words, we can say if the one particular person has a particular practical hand, then from that person there is a very little chance of having personal errors. Okay, so this is all about the personal and operational errors. Let us see again, what are personal and operational errors? These are physical in nature, and these errors occurs due to the inability of an individual to do particular analysis, to do particular experiment. Okay, these are that particular person is responsible only for the occurrence of such type of errors. Okay, and the examples I have taken number of examples: burette reading, then weighing, then mistakes in calculations, etc. Okay, elimination, how they can be eliminated? They can be eliminated by taking repeated measurements, or by taking practical hand, by doing same thing by number of ways, by number of times, let us say. And so that due to this we can get skill, practical skill or practical hand is gained by that particular person. So that's why we can eliminate these, we can fix and eliminate these personal or operational errors. Okay, now let us see second. The second type of error is called as instrumental and reagent error. Instrumental and reagent error. Second type, instrumental and reagent errors. Again, it is very simple to remember the explanation of instrumental and reagent errors. So again, what is the cause? What will be the cause of this error? What will be the cause? Some problems in instrument, or some problems in the reagent or solvent that we are using for that particular analysis. So this is the main reason, this is the main cause of occurrence of such type of errors in the analysis. Okay, means a particular instrument that we are using for the particular analysis, then if that instrument is not working properly, then error occurs. It is called instrumental error. For example, we have a pH meter. And the pH meter, and it is a analog pH meter, and it has a what we call a meter, analog meter. Okay, and if the zero of that marker or that pointer is not set properly, then we are getting the wrong results from that instrument. So this is the problem, or this is the problem of only that instrument, and due to that faulty instrument or mistake in that instrument, we are getting the wrong results. So this is the error occurring due to the instrument. Or reagent, or simply say the solvent. For example, when we are using a particular reagent and that reagent is impure, or that reagent or solvent may contain reactive impurity, then this reactive impurity may react with our main substance or our targeted molecule, our target substance. It may react with that our substance, our main substance. So there is a change in the final results. So that's why this is a very simple cause of instrumental and reagent errors. Okay, then examples. What are the examples? Again, I have told you that pH meter, or let us say any conductivity meter, or spectrophotometer, or potentiometer, any instrument for that we are using for that particular analysis, if they are faulty, if they are not calibrated properly, if they are not functioning well, then an error may be occurred. Okay, then another example, if some reagents or chemicals or solvents, if they have impurity, then they can be occurred in the wrong results in the final analysis of our experiment. Okay, so these are the examples. Then how we can elimination. How we can eliminate? For example, let us say any instrument is there. So pH meter is there, voltmeter is there, or conductivity meter is there. So do maintenance properly. Do maintenance, or we can say do repair. By repairing or by doing maintenance of these particular instruments, we can repair them, and whatever the fault in them, if we repair them, if we sort out that problem, then instrumental errors can be minimized or can be eliminated. Another thing is for about reagents or solvents, if we take most pure solvents, most pure reagents or solvents, most pure reagents or solvents, then there is a little chance of getting reagent errors. So these are the very simple ways from which we can eliminate the instrumental and reagent errors. Okay, so this is all about the second type of error. Then the third type of determinate or systematic error is errors of method. Errors of method. This is the third type, errors of method. So these are the errors which are along with the methodology that we are following for particular analysis, for particular experiment. Okay, so these are called as errors of method. Okay, means these errors originates from incorrect sampling. These errors originates from incorrect sampling. So this is one of the cause, incorrect sampling, and or incompleteness of a reaction. Means for doing a particular analysis, if we have to perform a particular reaction, then if the reaction is not completing, or it is completing only 80 to 90%, and finally we are doing analysis, then also errors of method is occurring. Okay, or it may occur from the incorrect sampling. So sampling is done incorrectly. So these errors are called as inherent. What is the meaning of inherent? Natural. These errors are inherent or natural in nature. They are occurring in the methodology or in the method that we are following for that particular analysis. Okay. For example, what are the examples of errors of method? In gravimetric analysis, in gravimetric analysis, what is the actual procedure? We are making a particular we are precipitating one of the compound, and after precipitating we will dry that substance, and after drying we ignite that substance. That procedure is called as incineration, means burning, or ignition. What we call ignition or incinerations means by means of burner we burn that precipitate, and if the precipitate is get decomposed, so the decomposition of the precipitate during ignition in the gravimetric analysis, so decomposition occurs, so it should not be occur during a gravimetric analysis, it should not be occur. Okay, so if decomposition occurs, then the error occurs, and that error is called as error of method. Okay, or sometimes precipitation is, we are getting precipitate, and during washing treatment of that precipitate by means of dropper and different washing solvents, if co-precipitation or post-precipitation, co-precipitation or post-precipitation is happening, then this is also an error of method. Okay, so these are the different examples of errors of method. Second examples is in volumetric analysis. We are doing titration, for example, phenolphthalein indicator is used for the acid-base titration. Phenolphthalein indicator is used for acid-base titration, and we know that the color of phenolphthalein in NaOH, that is in base, is colorless. In acid it is colorless, and in basic condition the color of phenolphthalein is pink in color, slightly pink in color. So we are doing a titration, and a particular stage will come. At that stage the end point is occurring, but the change in color is not visible to us properly. Okay, so the end point is, let us say 10.0 ml. This is the end point, exact end point or correct end point, but the change in color is not occurring properly. Then we are adding more titrant from the burette, and our result or our observation may get wrong. Okay, or sometimes what happens, the reaction between the titrant and titrant is not going to complete, and in such time we are going to add more and more titrant from the burette. The whole burette may get end, but your end point is not occurring. So this is what incompleteness of the reaction. There is no complete reaction between titrant and titrant, and that's why there is incompleteness of reaction occurs and error of method occurs. Okay, so this is all about the third method, errors of method. Now how these errors of method can be minimized. These errors can be minimized by means of changing the conditions of the experiment. These errors can be minimized or eliminated by changing the conditions of experiment. Okay, then the fourth one, the last one, is the additive and proportional errors. Additive and proportional errors. Additive and proportional errors. So what is this? Let us see first of all the additive errors. Actually these two are different, so we will take first additive errors. Additive means it is also called as constant errors. Additive errors are also called as constant errors. Why constant errors? Means in particular analysis the error is occurring, and if the amount of that error or the absolute value of that error, value of that error, or simply say absolute error, is getting constant, absolute error is getting constant in each reading, in each observation, then such errors are called as additive errors. For example, when you see example, then you can easily understand the meaning of additive error. For example, we are doing a titration, okay, we are doing a titration, and in first type of titration, our volume or our amount of that titrant added is, let us say 10 ml, okay. So the correct value or correct endpoint is 10 ml, but due to some errors, due to that particular error, we are getting the endpoint 10.1 ml. We are getting the 10.1 ml as an endpoint. Okay. So what is the absolute error here? 10.1. Sorry, 10 minus 10.1. It is 0.1. Okay. So the difference of these two, the error is 0.1 ml. Now we are increasing the volume. We are increasing the volume for that particular titration, and our increased volume is 20 ml. Okay. Now in this case, if the reading obtained is 20.1 ml, reading obtained is 20.1 ml, means we have doubled the volume of our titrant from 10 to 20 ml, but the error is again only 0.1 ml. The exact or the correct value is 20 ml, endpoint is 20 ml, but we are getting the results 20.1 ml. Again, what is the absolute value of error? It is again 0.1 ml. If we get triple the volume of that titrant added for that particular titration, that is 30 ml, and if we are getting observed value is 30.1 ml. Okay. So again, what is the absolute error? It is again 0.1 ml. It is again 0.1 ml. So that's why when we are increasing the volume or amount of that sample, we are getting the constant error. We are getting the constant error, and it is 0.1 ml. So the error value of absolute error is constant, it is 0.1 ml. Such error is called as additive error or constant error. Okay, such error is called as additive error or constant error. Then the second one in this case is proportional error. Proportional error. So they are comparable with each other, proportional errors. Okay. So in this case, absolute value of the error is not constant, but it is increasing proportionately. The absolute value of the error is increasing proportionately with the amount or the sample increased. Okay. Means what? Again, take the same example. We are doing a titration. For first titration of the same compounds, mean titrant and titrant are same, but only what we are changing? We are changing only the volume. In first case it is 10 ml, in the second case it is 20 ml, and in third case it is 30 ml. Here in first case the observed endpoint is 10.1 ml, so that's why the absolute error is 0.1 ml, no doubt. In second case, the expected result is 20 ml, but we are getting 20.2 ml as the endpoint. 20.2 ml as the endpoint. So what is the absolute error here? 0.2 ml. Okay, it is get increased from 0.1 to 0.2. And in third case, we triple the volume of the sample. The expected value is 30 ml, but we are getting 30.3 ml. We are getting 30.3 ml. So here 30.3 minus 30, the absolute value of error is 0.3 ml. Means what? As we are increasing the volume or amount of that sample from 10 to 20, 20 to 30, proportional to this, the value of error, absolute error, is also increasing from 0.1 to 0.2, 0.2 to 0.3 in proportion to the increased volume. So such errors are called as proportional errors. So additive and proportional errors are comparative. You can remember these things comparatively. Okay, so don't go through your textbooks. So very critical language is used in your textbooks. Just I have made some simple language notes, okay, for your explanation purpose. So remember these things as well. Okay, so this is all about the first type, that is determinate or systematic errors. Now see the second type is indeterminate errors. Second type is indeterminate errors. Second type is indeterminate errors. They are also called as non-systematic errors. They are also called as random errors or accidental errors. Random errors or accidental errors. So there are many names for these indeterminate errors. This is the second main class of indeterminate errors, that is second main class of errors, indeterminate or non-systematic or random or accidental errors. Okay, so these are the errors caused by unknown or uncontrollable factors. These are the errors. What is the cause of these errors? Unknown or uncontrollable factors. Means there are some reasons in the analysis due to which we cannot control, we cannot determine, we cannot analyze properly the cause of these errors. Okay, so that's why these are the unknown or uncontrollable. We can't control the occurrence of these errors. So this is the second type, indeterminate errors or non-systematic errors. So as they are indeterminate, we cannot determine properly, so they cannot be eliminated properly. Okay, so this is a very simple relation between this. We cannot eliminate properly, we cannot minimize or eliminate these errors properly. Okay, what are the examples here? What are the examples of indeterminate errors? For example, the needle of a pH meter. pH meter is analog pH meter is there, and let us say it is just like voltmeter or our ammeter that were used in physics laboratory at 11th 12th standard. Okay, and the voltmeter and ammeter has a needle, and if the needle is fluctuating continuously, of that milliammeter or voltmeter, just like this. Okay, and due to this we can't control, we have not control on such things. This is due to that problem which is originally present in that instrument, okay, and every time due to this fluctuation, every time this pH meter or that conductivity meter or that milliammeter or that voltmeter is giving wrong results or different results, okay. So why? Because there is a fluctuation. Or if there is a analytical balance that we are look or that we see in the shops or in the shops of greengrocers, that is vegetable sellers, okay. If that analytical balance, if the center of that analytical balance is not properly balanced, okay, it is again getting fluctuating. The one pan is going to downside and another pan is going to upside. It is not balancing properly. So when we take measurement or weighing on these balances, we are getting the wrong results. So this is, we have not control on such errors. So that's why these errors are called as accidental or random or indeterminate or non-systematic errors. So what is the elimination idea about this? Elimination, how we can eliminate them? These type of errors can be eliminated or minimized by taking multiple observations. Multiple observations. This is the only or simple way. Multiple observations and you can take, and then take an average. So take multiple observations and then take average about of all these observations. Then and then you can minimize, or you can the extent of that errors you can be minimized here, okay. So this is all about the classification of errors, okay. So errors are of two types, determinate and indeterminate. Determinate errors are of four types again, and indeterminate errors are of no types, okay. So this is all about the errors, okay. So thank you very much, have a nice day.